Okay. Let's take a look at these piecewise functions. We're going to finish up these piecewise functions today. Alrighty. So. Oh, no. My $5 microphone. Okay. So, not even, I think. Anyway. Let's review some of these piecewise functions, right? So how do we graph piecewise functions? Well, let's talk here at number 1, this first one we did. Does anyone not have this paper? Does anyone not have this paper? This is what we were working on Friday. We did 2 graphs on Friday. Okay, we did these 2 graphs. We had another paper we did before this one, but this is the one we last ended with. Okay. Does anyone need another copy of this paper? You need?
Oh, yes, I do.
Yes, Ethan? Okay. Does anyone else need a copy of this? Looks like that. It should be like we did it with that paper at some point. All right. Anyone else need one? You do too? Yeah, yes, it's that one. All right. Well, Mr. Stever, I'm sorry. I had to make some more copies. Apparently I didn't ask for the right amount. So I need like 4 more. Okay. More is just the case. Yes. Remind me at the end of class when I'll put you, okay? All right. So while Mr. Stever is making those copies for me one more time here.
I do have one.
Oh, you do have one. Okay. I was going to say, you guys, there's 2 papers, but anyway, okay. So what we're doing is graphing piecewise functions, okay? Piecewise functions look like this, okay? You can see that the function is equal to more than one thing, all right? We focused mostly on 2 or 3 things, right? So number 1 here had 2 functions. Number 3 here, or number 2 had 3 functions, right? Okay. So how we graph them, if you remember, right, is we would graph the entire function, right, 2x plus 3, and then we would erase away so that we only had the part of this function that was less than 0, for the x value is less than 0, okay? And then we would graph this entire function, and then we erase away only the parts where the x values were greater than or equal to 0, right? And then we evaluated here too. You can see that kind of looks like the graph from what we did in the warm-up today, okay? We're getting more copies here, Erica, too, if you lost it. So. Yep, we're going to go over again. So number 2, okay, similar idea. We graphed x plus 3, okay, which is a line, right, that has a y-intercept of 3 and a slope of 1. So we went up to 3, right, and we went up 1, right 1, up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1, down 1, left 1. But we only graphed the part that was less than 0, for the x value is to the left of 0. So we graphed this piece right here, right? And then we graphed 3 between 0 and 2. That's that horizontal line right there. And then we graph the 2x minus 1. There's that piece of 2x minus 1 for the x values that are greater than 2. Okay, and then we put it all together, and that's our graph. Okay? And of course, you can evaluate things here. For example, I can say, okay, f of negative 1, so we can locate there's negative 1. The function value there is going to be 2. Okay? And then I think, so Erica needed one, right? Who else? Oh, you found yours. Who else didn't have a paper still? Oh, sorry, Mr. Stever. I think people found them when you... Thank you. Okay, well, I have these spares in case something happens. Okay. And we can also evaluate f of 1. F of 1, there's 1 for the x-coordinate, and you go up to the function, and the function value there is 3. Okay? Let's do a few more of these graphs, though, right? I can talk it through, but it's easier to actually work it through, right? So let's look at number 3. Again, I would really encourage you to make sure you have a pencil handy, okay? Do this, oh gosh, I only have 1 pencil left, and I'm sure we're going to need more than that. So if you don't have a pencil handy, then just hold off. Oh, well, yeah. Okay, well, anyway.
I have a pencil.
I was going to say, yeah, if you have a pencil, then I would suggest you use that, and then we'll use like because we're going to be erasing things and stuff like that, okay? If you don't have a pencil, you can still do this, and I'll show you how to do it without a pencil, okay, without erasing and stuff like that. So we can talk about that too. Okay, let's look here. Okay, so we want to graph 3x plus 5, okay, that line. But we only want to graph it for x values that are less than or equal to negative 2. Okay? So in other words, we don't want to graph this thing for the entire graph. We only want to graph it for when its x values are less than or equal to negative 2. So let's start by graphing. Let's start graphing this line here. Where do I put my first point if I want to graph this? Okay, on 5 on the x-axis or y-axis? Y-axis. It's the y-intercept, right? 1, 2, 3, 4, 5. Now, here's where we're going to be different, right? Okay, if you... Well, all right, we'll just do this. All right, so we're going to put our point right there. Put it lightly, though, right? And then from this point, which way are we going to go? Up 3 over 1 or down 3 left 1. Down 3 left 1. Down 3 left 1. Down 3 left 1. Okay, and then you can connect those dots again lightly. Okay, and again, if you're using a pen, don't do what I'm doing right now. Okay, if you have a pen, don't do what I'm doing right now. You have to wait. Okay. And then, but let's take a look here. So that's the full line, but I'm only supposed to graph the piece of the line for x values that are less than or equal to negative 2. So let's find where is x equal to negative 2 here on my curve? Well, did I count this right? Oh man, I'm gonna be real upset if I didn't. I did count it right. Yeah, here's where x is equal to negative 2 on my graph, right? Right here, this point. Okay, and I only want to graph this thing for x values that are less than or equal to negative 2. So which direction is less than or equal to negative 2? To the left or to the right? Left for less than, right? So this piece is going to stay graphed. Everything else gets erased. You can highlight it, yes, if you want to highlight it. Yep. If you have your marker you want to highlight, you can go ahead and highlight this piece. Okay? Question? No? Grace? No? Okay.
Sorry, what's the point of
Erasing?
drawing the line? We're just going to erase it.
Well, we didn't erase. We have
Just
so
to be accurate.
basically, yeah, to make sure we have the points in the right spot. Okay.
So you're going all the way up to 2.
I started with the y-intercept of 5. Yeah, we go up to negative 2 and then we stop because that's what it says to do, right? We only graph this for x values that are less than or equal to negative 2. So once I get to negative 2, I have to stop. Now I will put a solid dot there though because it does have the equal to, right? Okay.
So you stop there because you don't want to go above negative 2.
Because it says, yeah, it says only graph this for x values less than or equal to negative 2. So I want to graph it. Now, the next one, okay, is the line x minus 4. So I'm going to go ahead and graph this line. So I'll count down. Let's see, negative 4 is my y-intercept. So 1, 2, 3. There's my y-intercept right there. And we're going to go, oh yeah, the slope of this line is what? 1. So we'll go up 1, right 1, up 1, right 1. I think I can just eyeball this here. And of course, down 1, left 1, down 1, left 1, down 1, left 1 as well. Okay, so there's the line, but, okay, where am I supposed to start this line? I'm only supposed to graph it for x values that are greater than 2. So I'm going to locate 2 on my x-axis right here, okay, and if I only want to graph it for x values greater than 2, does that mean I'm going to go to the right of 2 or to the left of 2? Right for greater than, right? Greater than goes to the right. So I'm only going to graph this part of my graph that's greater than 2. So I'm going to erase all the stuff here to the left of it. Okay, and we'll highlight to the right. Now, what kind of dot should I have at 2? Should it be open or should it be closed? Open or filled in? Open because it doesn't have the equal to there, right? So I'm going to erase this little solid dot that I have and put an open circle there. Okay, and so there it is. I'll go ahead and draw it in with my red marker now just so you guys can see it more. Okay, there's that. An open circle there. And just like that.
If we don't do an open circle, you take points off?
Yes, because you need to include the correct, endpoints and stuff like that too. Yes, you need to include the correct endpoints. Open circle. Look at the inequality symbol, Grayson. Look at the inequality symbol. Okay. Other questions? Okay. So, what's different about this piecewise function than the other two that we did prior to this? What's different about this piecewise function? Go ahead, Scott.
It doesn't connect.
Doesn't connect. Okay. That means it is discontinuous. continuous, okay? There's a break in it here, and you can see you get this weird graph, okay? So, let's answer some of these questions. What is the value of the function at 2? John says there isn't one. Let's take a look here. Here's the x-coordinate of 2. What is the value of f? Well, our curve is down here, but what happens when we get to this point right here? It's an open circle, right? And so it doesn't exist. Okay? Doesn't exist. There's a hole there. What about at -3? What's f of -3? Well, let's go -1, -2, -3. We'll go down to right here. I think that's the point. Okay, right there. The y-coordinate there is -1, 2, 3, 4. So -4. What about f of 0? What is the value of the function at 0? Doesn't exist. At 0, there is no graph there. Right? There's no graph there at 0. And that's the answer again is doesn't exist. Okay? Questions on any of that? All right, turn the paper over here. We'll do one more together, and then I'll have you guys try one on your own. Okay, we'll do one more together, and I'll have you guys try one on your own. Actually, maybe I'll do this. Okay. Here's what I'm actually going to have you do. I'm going to have you guys start this one on your own. So I want you to go ahead and graph this line, and I want you to go ahead and graph this line. Okay, just graph these two lines. Don't worry about what part you're supposed to erase or not. If you want to try and figure it out, feel free to do that. But at least graph these two lines, okay? So again, put down your y-intercept and then use your slope to get more points, okay, for both these two lines. So go ahead and do that right now. Graph those two lines. Yeah. I do. Yes, Grace. Yeah, go ahead.
Thank you.
You're doing it very good. Good job graphing on that. Correct. Correct. Okay. So again, let's go ahead and graph these two lines here, folks. I'll graph them as well.
Wait, so for the first one, do I just point and then move it? Because there's nothing?
What's the y-intercept? No. That's the slope, 0. So start at 0, and then use your slope to get more points. Okay, so graph your lines here. Try and graph each one of these two lines. Use your slope intercept form there to help yourself, okay? Graph each one of these two lines right there. Okay, so you can do just graph the two lines. Okay. Let's see. Okay, yeah, oh, I see what you're doing. You're erasing stuff. Okay, gotcha. Okay, graph the two lines there. Be careful. The slope of this one was negative x. Just be careful. Graph those two lines. Find the y-intercept there. Okay. Graph slope intercept form. Use slope intercept form here, Alessandro.
I just want to make sure I'm doing it. So if it wasn't greater, it would be this over here.
So yeah, you want to graph the x values to the left of 0. And including the 0.
And then for that one,
You want to graph the parts to the right of 0. So Alessandro, the first equation you're trying to graph there is x. Sorry, x right there, right? So what's the y-intercept? What's the b? There's no number written, is there? It's 0. It's not written. It's plus 0, right? It'd be a 0 kind of thing. And then what's the slope? What's the number in front of the x? 1. So put your slope your y-intercept there at 0, and then count using your slope to get more points. So up 1 right, down 1 right. And the same thing then for this line. Okay. Yeah. Yep. And then make sure you put like an open circle or a filled-in circle, depending on whether it's got an equal to or not. And then you're done. And then of course erase the other pieces.
well, this one was.
Okay. 30 more seconds here, and then we'll take a look at the graphs. But be careful, you went down one and left one. So for it's, when it's negative, that means you have negative one over positive one. So that should go down one, right one, or up one, left one, up one, left one. Yes, that's the idea. Okay. Okay. Here's what our graphs should look like without the restrictions, right? Without restrictions. So forget about the restrictions. There's just the two graphs. Okay. This is y equals x right here. And then this right here is negative x plus 4. Okay. All right. So for this y equals x, we're only supposed to graph y equals x for x values that are less than or equal to 0. So we're going to find the x values at 0. So there's where x is 0. Whoops. There's where x is 0, right? And we want to go less than or equal to 0. So from this x value of 0, if we want to go less than 0, should I graph to the left or should I graph to the right? For less than 0, we're going to go to the left. So I'm going to just kind of shade, not shade, but highlight, there. To the left, like that. Okay. What kind of dot should I have at 0? Should it be filled in or open? What does this tell me to do? Go ahead, Jackson. Just filled in. Yeah, very good. So solid dot right there. Okay. And so I will erase the rest of that line. I didn't draw it very lightly there, but. Okay. There's the red piece. All right, cool. Now for the next one, I'm talking about my negative x plus 4, and I'm graphing it only for x values greater than 0. Okay, so again, here is where my graph has an x value of 0 right there, and I want to graph x values greater than 0. So does that mean I want to graph to the right or to the left? For greater than 0 to the right, right? So from this point, I'm going to go to the right. Okay, and just highlight there. That means I'm going to erase this piece back here. Okay. What kind of dot should I put here? Open or closed? Well, I heard open and closed. There's no equal to, right? So open. Okay, and so there's our piecewise function. Okay. Is this piecewise function continuous or discontinuous? Discontinuous. Why, Olivia?
Because it's not connected.
It's not connected. There's a break. Yeah, it jumps. You got it. Okay. All right, so let's answer a few more questions here. Is it a function, though? Yes or no? Is it a function? How do we determine if something's a function or not? What's the test that we use? You guys remember? It had a name. Frank? Vertical line test. Vertical line test. Is that what you're going to say, Alessandro? Vertical line? Yeah, that's good. That's right. Okay. So how do we use a vertical line test to tell if this is a function or not? What are we looking for? So, Anna? Okay. So, yes, along those lines. Okay. So if we graph any vertical line, we would want that vertical line to only intersect our graph how many times? One time. Okay? So is there any place here, if I were to graph a vertical line, that these two functions, where my vertical line would hit more than one point?
On the y-axis.
On the y-axis. Yeah, let's take a look here. So on the y-axis, I hit a point right here. But then if I keep going up, wait, what's this?
It's not there.
It's not a point. So will I hit 2 points here? No, I'll hit this one, but not this one. So is there a place where a vertical line will hit more than once? No. So that means this thing is a function. It is a function, believe it or not. It's not continuous, it's discontinuous, right? But it is a function. Okay. All right. Let's evaluate some of these here. What's f of negative 4? Yeah, I mean, if you look here, negative 1, 2, 3, 4. So there's the x coordinate negative 4. The y value is also negative 4. So it's just negative 4 there. Okay. F of 0. What's f of 0? 0. Yeah, it's where it crosses the origin there. What about f of 3? Let's count here. 1, 2, 3, and you go up to your function. Yeah, it's 1. Okay? You can also use the piecewise function to evaluate this. For example, if I want to evaluate f of negative 4, okay, which part of my piecewise function do I plug it into? The top one or the bottom one? If I want to evaluate f at negative 4, should I plug this negative 4 into the top piece or the bottom piece? Why the top? It is the top. Why the top?
Because it's included in equal or...
Yeah, negative 4, right? This x value of negative 4 is less than or equal to 0, so we got to plug it in this top one, so we also get negative 4, right? Whereas when we do 3, right, 3 is greater than 0, right? 3 is not less than or equal to 0, so we wouldn't use the top one. 3 is greater than 0, so we use this bottom one here. What's negative 3 plus 4? That's 1. So there's your answer. All right. Go ahead and try number 6. I want you to try and do the whole thing there. Okay, try and do the whole thing there for number 6. Okay. Now, be careful here. How do you graph a graph like 5? What does the graph of 5 look like? It's a horizontal line. It is 5 over 1, but it's a horizontal line that goes through the y value of 5. Okay, this is going to be a horizontal line. So go ahead, guys, give it a try there. Okay, give number 6 a try. I want you to try the whole thing on your own. Okay, see what you can come up with there, and I'll do it as well. Okay, so go ahead, try number 5. Yep.
So I would start at 0 again.
To graph 5, you would just count up to 5 on the y-axis and then draw a horizontal line through that 5. Okay, so go ahead, try and graph the other part there too. That's what I'm doing. So if you want to hold off, you wait until we do the rest of it, feel free, or if you want to keep trying. If you want to actually like erase the pieces and stuff, go ahead and do that too. Okay, are you okay, Alexia, with graphing this? You need some help? You good? Okay. Jackson, you doing okay graphing this stuff? Okay. So remember, you don't. Oh, I see. You're trying to like graph the actual pieces here. To do that, remember you want to put the division symbol in there. So I'm just show you all that. So you want to put like. It kind of works what you were doing there, but you really want to divide by your arguments.
I did it similar to this one.
And it worked okay?
Yeah, but except for account for lines here.
Yes.
That
Yes.
was
Yes.
weird.
Dividing will make it work better. So it's just up 5. So 1, 2, 3, 4, 5, and there's a point there. That's actually your B. There's no x next to it, so that's the B.
So there's no...
There's no slope. The slope is 0, so you're actually it's going to go straight left and right to the horizontal line. Okay.
No, I'm not. That's not
Yes.
you get 8. So for the
That was good. Yeah, that's the right.
He's making fun of me for the reason. Would you
I slept the whole time.
because the X everything's bigger, but the
I got
So you're talking about graphing this right here?
yeah.
So if x value is greater than 3, you're going to go to the right of this. You're going to graph the part of this, and this is right. Erase anything to the left. Yep.
Since this is negative, can you bring them
Down to right. If you down 2 and left 1, you're doing negative in the numerator and denominator then.
So that would just be negative 3.
Yes, I would make it negative 2 over 1
Yeah, you must
as
do
a
it
fraction.
yourself.
Okay, so we go down to right. Okay. Anyone having trouble? Alright, so that's looking good so far, Trey. Or we can graph the bottom graph too. Okay, that's looking pretty good too, yes. Okay, what's that? Trey, don't give up. Look, this is in slope-intercept form. What is the y-intercept of this line? What's that? Negative 3. So you're going to start on the y-axis, negative 3, and then what's your slope of this line?
Oh.
What's the slope?
2.
Negative 2. So you're going to go, how are you going to go?
Well, you are right.
You're going to go down and right, or up and left. Down and right, up and left. Yeah.
Hey, listen, where's your paper? I saw that. Where's your paper?
Nice first one, so first thing one.
Oh, great. Do you need another paper? I'm sorry you're not feeling well, but I just want to make sure that you're able to get this stuff though too.
Since I know how to do it.
I think Eric is out when Eric comes back, unless it's an emergency. In which case.
Yeah, kind of.
So x greater than negative 3. So you want to graph this for x greater than negative 3.
Oh, I have
This would be for x less than.
I got kicked off one too.
Me too.
You just have
I used to run.
I love it.
Those things are some. I find them so frustrating.
So what are you talking about?
Okay. Give you like 1 or 2 more minutes here, folks. Let's try and finish this up. Okay, if you need help, let's get going here. Okay, make sure you got to graph these things. You don't get better at it by not trying. Okay, you won't get better by not trying. Please don't give up. Okay, you give up, and that's game over. Okay, you got to try these here. Give them a graph. All right. See what you can graph there. You try where? So 5. Where's so that's your B, right? There's no M. Just B is 5. So where's the y from 5? Okay, and so then you have no slope, so it's a 0 slope. It goes left, right. So it's horizontal line. Okay.
So for this,
Okay, be careful. What's your y-intercept for this line? Nope. What's your y-intercept for this line? Negative 3. So where's your point?
I keep thinking that's the X.
I know you did. I saw. Yeah. So what's your point where it's supposed to be? There you go. And then you just slope to get more points, right? Negative 2 over 1. So down 2 right, 1 down 2 right. Start this right here. Okay, you have the right start, and we're gonna finish it up. Well, actually, erase that this whole line. You need to have your y-intercept is at negative 3. You have to plot that negative 3 y-intercept there. Okay. All right. In the interest of time here, I'm going to go ahead and show you. Here's what the 2 lines should look like together. Okay. Here are the 2 lines together here. Okay. So 5. Okay, there's our horizontal line at 5. How do I know it's horizontal line? Because this 5, there's no x to it. That's our b. The b is 5. Okay, y-intercept of 5, and there's no slope. So it means your slope is 0. You're going left and right. You're not going up or down at all, just left and right. Okay, and then for this right here, your y-intercept is negative 3, and your slope is negative 2, or as a fraction, negative 2 over 1. So down 2, right 1, down 2, right 1. Of course, up 2, left 1, up 2, left 1, up 2, left 1. Okay, all right. So now, let's take a look at how we're going to erase, or what we're going to highlight here, right? Let's highlight it first before we erase. So, x value is less than or equal to negative 3. So here's my horizontal line. There's the 5, right there. X value is less than or equal to negative 3. So I'm going to find negative 1, 2, 3. There's where x is negative 3. And this inequality symbol is less than or greater than, or less than or equal to or greater than equal to. What is this inequality symbol? Less than or equal to. So that means I should highlight to the left, or I should highlight to the right for less than. Left. So solid dot because it's in the equal to. I'm going to highlight to the left. Okay, just like that. Now for this next one, there's my negative 2x minus 3. Okay. Again, there's negative 3. Should I put an open or filled in dot here for this one? Open, right, because it doesn't have an equal to. And then it's a, what is this? Greater than, less than, greater than equal to, or less than equal to? Greater than. So should I shade to the right for greater than, or shade to the left for greater than?
Right.
Shade to the right, or highlight to the right, I should say. So highlight to the right. Okay, just like that, and then we'll erase that. We'll erase that line right there. So erase anything that's not highlighted there, right? Okay, and there's what you should have gotten. Okay, is it a function? Does it pass the vertical line test? It does. Any vertical line you draw, including right here, would hit at this point, but go through the open circle. So yes, it is a function. Okay? If I want to evaluate f of -4, which piece of my piecewise function do I plug it into? Top or bottom? If I want to evaluate f of -4, where should I plug it in? The top piece or the bottom piece? What do we say here, folks? If I want to plug in -4, should I plug it in the top piece or the bottom piece? Top. Why? Yeah, -4 is less than or equal to -3, so it's the top piece. So what is f of -4 then? What do we get? It's 5. Yeah, it's just this 5, right? It's always 5. Any x value that's less than or equal to -3 has a y value of 5, according to that. What's f of 0? Well, which piece should I plug it into? The top piece or the bottom piece? Is 0 less than or equal to -3? So we plug in the bottom piece, right? 0 is greater than -3. So we plug it in here. -2 times 0, 0, minus 3, -3. Okay? And then the last piece here, number 6. Okay, what's -2 times 3? Oh, shoot. Should I plug it in the bottom one? Yes, 3 is greater than -3. So -2 times 3 is -6, minus 3 gives us -9. Okay? So there are those pieces there. All right? Questions on any of that? Folks, let me tell you something. Piecewise is hard. You probably knew that, right? I mean, you didn't need me to tell you that. But every math student has difficulty with these. So if you're finding them difficult, okay, I mean, you know, obviously I understand you being frustrated and stuff like that. But like every math students that I've ever taught, all math students that I've ever taught from every level, okay, people that really think they're strong in math, people that think they're really weak in math, they find piecewise functions difficult. So if you find these difficult, you are in good company, okay? It's not easy. It's not an easy topic, all right? But you can get better at them. That's the thing you got to keep in mind, right? It's not something that you can never understand. You can get better, but you got to put the effort in. All right? One more paper here. Why don't you wait for just a minute here, Brady? I want to talk about a function here real quick, and then we'll
What's that, like? Mr. Lamar, what is that?
take one test that. Well, it's got a name. Do you see it? The step function. All right, in fact, let's go ahead and just jump down to that step function because I think that's a little more interesting. Okay. Thank you. So we're gonna skip this one for right now. We'll come back to this. We'll do that for some practice here in just a second. But let's take a look at this weird function right here. Okay. This is called the step function. Do you see why it's called the step function? It looks like steps. Yes. Okay. So what is the point of a step function? So, well, if you look here, let me just see here. Okay, so why might we learn about the step function right here? Why are we talking about the step function, you think? How does it relate to what we were just talking about? It doesn't? Well, I think it does. How can we relate it to what we were just talking about? What about this graph relates to what we were just talking about? The piecewise functions. How does it relate to piecewise functions?
Graph.
It's a graph, yes.
We're getting closer.
It is a graph. Open circles and closed circles, right? Okay. There's just a bunch of pieces here, right? I mean, this is a piecewise function, isn't it? It's a bunch of pieces of other graphs, okay? In this case, though, it's a piece of several horizontal lines, right? And they're kind of like all made in the same kind of fashion here, okay? So this is called I'm trying to think about what the name of this is. I can't remember what this is. I think it's called like the least integer function. Anyway, what this function does right here, when you see this like kind of like double square brackets like this around x, what it does is any x value that you plug in here, okay, it gets rid of the decimal, and the output is whatever that is with getting rid of the decimal. So for example here, if you put in like 0.5, it throws out the 0.5 and it says your y is 0. And so that's why you get this, all these y values here are 0. And then between 1 and 2, right, all these fractions like 1.1, 1.2, 1.3, they get rid of all the decimals and they have an output of just 1. And then any number between 2 and any x value between 2 and 3 becomes just a y value of 2. And then between 3 and 4 becomes a y value of 3, so on and so forth, right? So let's just look at this, okay? According to this graph, what is f of 0? 0, yeah, okay? According to this graph, what is f of 1.5? So if you look here, here's 1, there's 2, and here's 1.5. What's the y value associated with this x value? It's 1, right? Yes, it's 1. How about f of 1? What's f of 1? 1. What's f of negative 3? Well, now we got to go over here to negative 3, right? What's the y value associated with negative 3? Yeah, negative 3 there, yep. Okay. What's f of 2.5? 2.5 is 2, yeah. Okay. What's f of negative 1? Negative 1. Okay. What's the domain? Negative infinity to infinity. Yes. But wait a minute. What about all these open circles?
Wouldn't it always be negative infinity?
But the open circles also all have solid dots above them. So this 1 here, although it has an open circle, there's an x value of 1 right here. And this 2, although it has an open circle, there's an x value of 2 right there, and so on and so forth on up. So yes, the domain is negative infinity to infinity. Is the range also negative infinity to infinity?
Yes.
No.
Yeah, not quite. We're missing stuff like negative, or like 0.5, right? There's no y value of 0.5. So how might we describe the range here?
Undecisive.
It's like all the integers. So we could say something like this. This is kind of hard to describe. We could say ... like negative 3, negative 2, negative 1, 0, 1, 2, 3, comma ... You could also just say all integers too.
I just put
To infinity.
Okay, what's that?
Can I just put
Etc. Sure, if you want to. etc. If you're into the Latin, for sure. Et cetera. Cetera. So this is the step function, okay? And it's famous as a piecewise function. It's like a named piecewise function. Okay? All right, let's go up to this top one here and graph this piece.
I am down.
Okay? You're down?
Oh, no, never mind.
Never mind. Forget it. Forget about it.
I have to talk to Teresa Alvin's office.
Dr. Allen? Pencil? Oh, okay. Here's one which you'll have to sharpen. All right, let's graph this thing. So I'm going to start calling on some folks here, telling people to answer stuff. All right, so let's go to Olivia. Olivia, let's graph this piece first. Olivia, is this going? What kind of graph? What's the graph of this thing going to be? What's the shape of it? Is it linear, quadratic, exponential? What's this thing going to be? What's that? Linear. Very good. Thank you, Olivia. Let's go to someone else. Let's go to Erica. Erica, it's linear. What's the y-intercept of this line going to be? So what?
linear.
Okay, it's linear. What's the y-intercept going to be? What number, what value is the y-intercept here? 2. Yes, it's the b, right? It's 2. So I'm going to put my pencil here on 2. Okay, and lightly put a y-intercept. Very good. Thank you, Erica. Let's go to Grayson. Grayson, what's the slope of this line? Hold on. 3 over 1. So it means from this y-intercept, Grayson, we're going to do what?
Go up 3.
Up 1, 2, 3, right 1.
3 left.
Yeah, so up 3, right 1. Up, oh, I ran out of space. Down 3, left 1. Down 3, left 1. Okay, and then connect those dots lightly with a pencil. Oof. Yikes. Okay, well, that'll be okay, I think. Something like that. Okay. Very good. Let's now go to Alex. Alex with an X. Alex, is this linear, quadratic, exponential? The second equation here. Linear, very good, linear. All right, let's go to Sierra. Sierra, what's the y-intercept of this line right here? Very good, -5. So on the y-axis, -5, put a point. Okay, thank you, Sierra. Let's go to Lily. Lily, what's the slope of this line? 1/3. So from here, we're going to go from our -5 y-intercept that Sierra told us about, we're going to go up 1, over to the right, or over to the left? To the right. Up 1, right 3, up 1, right 3. Or we could go, instead of up 1, right 3, Lily, we could also go down 1, left 3, down 1, left 3, down 1, left 3. Then connect the dots. Okay? Just like that. Thank you, Lily. Let's go to Miss Jazzy. All right, Jasmine. If we want to graph x values less than 3 here, Miss Jasmine. Okay, sorry, I'll just say Jasmine. X values less than 3. So I'm going to go to 3 right here. Oh, wait, which curve am I on? Shoot, I got to remember here. X values less than 3 for 3x plus 2. Here's the 3x plus 2. I got to go to 3, which is all the way. Oh, that's really sad that they did that to us. It's like up here somewhere. Somewhere like right there, we'll say. Okay, so if we want to graph, if we want to highlight here, if we want to go less than 3, should I go left on my curve or right on my curve? For less than 3, left. So with my pen, here's 3, and I'll go shade to the left. Oh, by the way, what kind of circle should I have here, Jasmine? Should it be open or closed with my inequality symbol that I've got? Should it be open or filled in? Open, because it's not equal to. Yeah, open circle there, and then we'll go all the way left. So all the graph to the left there. Keep going, keep going, keep going. Okay. All right, Jasmine, well done. Thank you, Jasmine. Let's go to Kaylee. Kaylee, now for the other piece, I'm supposed to graph it for x values greater than or equal to 3. So I will, again, here's my other line, 1/3 x minus 5. I want to graph it for x values greater than or equal to 3. So here's x value 3. I'll go to my graph. What kind of dot should I put here? Open or closed? Closed, right, filled in. So filled in dot. And then do I want to shade to the right for greater than or to the left for greater than? Right. To the right. And then we'll erase away that other pencil stuff. Yes, go ahead there, Brady. Thank you for waiting. Okay. Yes.
For the one line, the longer line, I want you to rate it because it's saying numbers that are last.
Talking about this one right here?
Yeah.
Why did I go which way?
Why did you highlight it all?
Why we highlight it all? Because we have found the x value of 3. So here's the x value 3, and it was right here on our graph when the x value is 3. Then we're graphing all x values less than 3. Less than 3 means to the left, and so we graph everything to the left. And it just so happens that it had all the graph there. Okay. All right, so letter A here, what was our boundary line? At what x value? Let's go to Chloe. Chloe, at what x value do we switch over here? What's the boundary here? What's this x value where we switch? What's x value here, Chloe? Do we switch from this graph to this graph? At what x value do we switch? You need me to zoom in some for you there? At what x value do we switch between those two pieces of the graph? Not sure? Well, do you see where they switch? Like here's this graph and we jump to this graph, right? So at what x value are they kind of like ending and starting? Can you see it? It's close. It's not 4. Kaylee, you want to help out? Where is it switching? At what x value? At what x value are we switching from one graph to the other graph? 3. Yeah, it's 3. 3. It's our borderline. It's our boundary line, okay? 3 is where we kind of like switch over, okay? And so let's again evaluate here. I can't quite read letter B. I think it's supposed to be a negative. No, that can't be negative 8 because that won't be negative 6, you think, or negative 2? All right, let's just make it negative. Yeah, let's do negative 2 because I don't think we'll be able to see negative 6 either. We'll just make it negative 2 because we won't be able to see the negative 6. Although I guess we can just plug it in. Let's make it negative 2 though, just because. Okay. All right, so negative 2. Now again, we don't need to use our graph. Which piece of our function can we plug it into? The top or bottom? If we're trying to evaluate f of negative 2 here, folks, should we plug it in the top piece or the bottom piece?
Or not the top.
Yeah, the top, because negative 2 is less than 3. So we want to use the top piece here, so it'll be 3 times negative 2 plus 2. Negative 6 plus 2 is negative 4. Okay? And then 0. Okay? 0 in the top as well, because again, 0 is less than 3, so it'll be 3 times 0 plus 2, so we'll get 2. And then finally for 3 should go in the top piece or the bottom piece? Yeah, bottom, because 3 is equal to 3, so we'll have 1/3 times 3 minus 5. 1/3 of 3 is 1, minus 5 will be negative 4. Okay, questions on any of that? Question? Brady's out right now. When he comes back, yes. All right, flip your paper over. Flip your paper over. Okay, so now we're going to go backwards. Backwards. Now we've got a graph, and we're going to come up with a piecewise function that defines the graph. What's that? You don't like this? So you don't like this and you don't like this? Or this sounds worse? Okay. Good. I'm glad you think so. Okay, so let's try and break it down here. Because this is a lot, potentially, to take it all in at once. Let's read through the situation here. Julian is training for a race and has a routine for his workout. Let x represent the time in minutes, so these are time in minutes, of Julian's workout, and f of x, the y values, represents the total amount of blocks from home. The graph below models Julian's workout. Okay? So.
Can I highlight this?
Yeah, if you want to highlight. Yeah, sure, if you want to. Okay, now. How many pieces are there in our piecewise function? Look at the graph. How many pieces are there in our piecewise function? There's 4, yeah. 1, and I'll number them here. There's number 1, right here. There's 2, there's 3, and there's 4. Okay, there's our 4 pieces, I mean. Okay. Each piece is what kind of graph? What kind of shape is each piece? They're all what? Lines. Lines. They're all lines. They're all straight lines. Okay? And so we're going to come up with linear equations for each one of these pieces. All right? Let's look at this first piece. This is probably the easiest one to do. Okay? To write the equation of a line, let's use slope-intercept form, right? Because you can see right down here, they want us to put in slope-intercept form. There's mx plus b, mx plus b, mx plus b, mx plus b. Okay? What is the y-intercept of this first line right here? 0, right? Looks like it intersects right there at 0. So we're going to put 0 for our b. And then what's the slope? It's 3 over 1. Yeah, count up 1, 2, 3, right 1. There you go. Up 1, 2, 3, right 1. Yep, up 1, 2, 3, right 1. Yes. So the slope is 3 over 1, or just 3 if you like. Okay. Now, where does... Oh, go ahead.
Wouldn't it be greater than or less than 3?
So yeah, we're going to be less than or equal to 3, but greater than or equal to what number? Where do we start? Actually, at 0. So it's between 0 and times 0 and 3. 0 and 3 minutes, that's what the piece is. Okay? So that was step 1. Again, we found the y-intercept there was 0. The slope was 3, because we went up 3, right 1. And then it started at 0, x value, and went to 3, right? The piece started at 0 and went to 3. That was our borderline right there. So there's a borderline. There's a borderline right there. There's a borderline right there at 10 as well. Okay, there are 3 borderlines. Okay, so you can see like right there, and right there. Those are our 3 borderlines there.
Wait, 3, 6,
3, 6, and 10, I would say. Yep. Okay. Question so far? Okay. Let's go to someone else here then. All right. So how about someone. Let's see here. 15 is no. I think 15 is all. It stops then at 15. It stops at 15. Okay. So let's go to this next one here. Part 2. Okay. So here is part 1 right there. We're going to do part 2 right here. Okay. So Cameron, what would be the y-intercept of this line? Yes, very good. If we extended it, right, it would intersect right there at 9. So our b is going to be 9. Cameron, what's the slope, though?
0.
Yeah, very good. 0. Very good. Yes. 0x plus 9. Or if you're writing it on your own, you can also just put y equals 9. That'd be fine, too. Or just 9, I mean. That's fine. Cameron, at what x value does this second piece here start? What's the x value where it starts? 3. And what's the x value where it stops, Cameron? 6. So there you go, from 3 to 6. Okay, good. Questions on any of that? All right. Let's go to Lauren. Lauren, for this piece right here, number 3, okay? Is it easy for you to tell what the y-intercept is for this piece? Yeah, not really. Can you tell me what the slope is at least? Let's at least try and do the slope here. What's the slope of this piece for number 3? Can you count it? Yeah, 1/2. Up 1, right 2. 1/2. Very good. So, guys, what can we maybe try and do here to figure out what the y-intercept is? Jackson, do you have an idea?
Pencil next to the line. Kind of got 6.
Okay, you use like a straight edge, and then you put it next to the line, and you think it's going to intersect at 6. Let's see if Jackson's method here works pretty well. So I line those up, and yeah, it looks like I'm going to hit 6, right? 6 is like the closest number I see right there. Okay. What else could we do if we want to be maybe more precise? What's that? You could use a calculator to graph. Okay. Yes. So let's maybe use our slope to count back to the y-intercept. Right. So Lauren did a good job giving us a slope. That's super important. Instead of going up 1, right 2, shouldn't we be able to go down 1, left 2, and just keep going? Down 1, left 2. Down 1, left 2. Down 1, left 2. Was Jackson right? He was. -6. Okay. Good job there. Okay. So Jackson, where does that section, that third section here, where's our third piece, where does that start? At what x value? At 6. That's right. And then Jackson, where does it stop? At 10. Yeah, it's 10. Yep, it's a 10. Okay, last piece. Let's go to Trey. Trey, can you tell me, just give me the slope for this one first. How about that? What's the slope for this fourth piece? So can you count it? Pick a point. Let's pick this one right here. How do I count to get to this next point right here? How would I have to go? Up 1 over 1. So what's the slope? 1 over 1, or just 1 if you like, but we can put 1 over 1. Yep. All right. So again, we could use Jackson's idea there of trying to line up our pencils and use that to help guide us. I don't know if my pencil's quite long enough there. Or we can just count back. So instead of going up 1, right 1, we'll go down 1, left 1, 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 down 1, left 1. -1. Okay, Trey, for this particular fourth section right here, Trey, all right, for that fourth section, what is the x value where we start that fourth section? 10, and where does it stop? I think in this case it actually does stop 15. There you go, yeah, 15. Okay, so there we did it, folks. We wrote a piecewise function, okay? So for homework tonight, there isn't any. We just did it, okay? So no homework tonight, okay? So any set requests for tomorrow? Hannah T, I know, has already asked. All right, me, Grayson. All right, Trey, Hannah T, Kaylee S. Who else? Alessandro, you got it. Anybody else for set tomorrow? Brady, did you say you wanted to come in? Okay, sorry. All done, sir? I did. Yes. Yeah.
My brother tried
I almost tried 2 or 3 times. legit almost cried 2 or 3 times, and then I got like goosebumps a couple times too. So, yeah.
This one guy that he says that was saying it was so good.
Wyatt Hagee, do you know who he is? He's a senior. He's seen it 4 times already.
I've seen it twice.
Yeah.
I just went back to see all the Hard 5 Minutes when I was drinking.
No, I haven't. Is that right? No, I haven't been able to because, like, I don't have, like, I mean, I guess, like, aren't you able to wait and see it? Is that right? So, like, would you have to pay for it, or it's you can pay for it? Okay, but if I watch it back, it's free then? Yeah. Okay.
I just want to play with
Right. I don't do that, so I'd have to use Crunchyroll, I guess. Is One Punch Man on Crunchyroll too?
I don't know.
Okay.
But
Okay. Did they have a free version too?
yeah.
Okay.
One Punch Man's on Netflix, I think.
Not the season 2.
Not season
Same thing with Stupid Attack on Titan 2. They don't release any of that new season stuff. So anyway, sorry, Jeff. Theater, how much are Westview?
Oh, my
Did you
brother
see
was
Endgame?
the one in Virginia.
Oh, that-
they're kind of season.
Oh, very nice.
And like,
That satisfied me.
I was it's impressive. I don't know like how the next phase is gonna go. You know what I'm
I don't
saying?
know how they can top that.
Right, exactly. Yeah. Oh, okay, that's a good one though. Oh, okay.
yeah, well,
Wow.
towards the end.
I mean, well, I hear what you're saying. I mean, I've been watching since the beginning, since Iron Man, basically. So I haven't seen all of them. Like, I never saw Thor: The Dark World, and I feel like I missed like.
No one watches Thor.
Yeah. Like Thor: Ragnarok was one of my favorite ones. And
Yeah, that was a really good one.
what's that? Yeah.
I just got it on the PS4.
Oh, 11 or whatever. See, I was alive when that first came out. Mortal Kombat 1. I was in elementary school, so it's very violent. Even more so than it was back when I played it.
My brother showed me that some of them are really unnecessary.
Yes, I agree. But no, I know. Endgame, and the only thing that I'm like, again, because they like kind of hinted in the future or whatever, like what they're gonna do. And the only thing I'm kind of really excited about is that Thor is gonna do with Guardians of the Galaxy.
Yeah.
Like that seems really cool.
But I'm like, and Falcon.
Falcon's Captain America.
Yeah.
I'm curious to see. That one's weird to me because like he's not a super he has no super soldier serum, so like he's not.
Yeah, but in like the comics, I heard that's how it goes.
Right, but I'm just like, how? So are they gonna make him a super soldier? Like, I don't know. Like, how's he gonna be able? He won't be as strong as Captain America. Is what I'm trying to say.
True.
You know what I'm saying? So, all right, folks, have a good day.
I'm talking to my friends. Like, just admit that he used the stones to commit suicide.
Yeah, basically,
He
that's
just made
true.
the stones commit suicide.
That's true. That's true. All right, have a good day, folks. Let's hope you feel better. Grayson, oh man.